So what we're going to be working on are these buildings that we like to call post-tension slab on grade with ribs. And we've had a few projects where we've worked on these, but what tends to happen with these is that they work at, or that they're used at maybe apartment complexes where they're building a bunch of buildings that might be very, very similar, have similar types, but based off of the site conditions like the ground level, where how the soil slopes, things like that, there might need to be some differences. So a project that we worked on before was called Aspgren Park. And this is just to give you an idea of what some of these buildings might look like. What you can see here is that we've got, usually there's like a flat slab, and then oftentimes it meets up with some sort of sloping slab. And usually what's happening here is that there's going to be some sort of storefront, maybe, or probably in this case, what it really is something that's got ground floor apartments. But then what we have is we've got these sloping slabs here, and these ones are for garages. So you need to make sure, because there's oils and liquids and things like that in garages, we need to make sure that they're sloping. Um, and so what usually happens is that you've got this flat slab and maybe it steps down to a garage, or maybe it slopes from the same place. So you kind of here, it looks like it just kind of slopes from the same spot. And then what you end up having to have between those are curbs between, say, each garage. And this can be a bit difficult to deal with, um, but essentially the purpose of the curb is that you want a wall on top of these to divide the garages into different pieces or into different rooms and spaces. But you need a flat area for the curb, or sorry, for that wall to sit on. So what we do is we put a curb in here. Uh, Now, depending on the complexity of the building, what we might have so what we had in this case is we had a slab that was of varying thickness, because what we ended up having was we have a bunch of ribs underneath. And let me show you what I mean by a slab of varying thickness. So if we isolate this element, we can see over here, this is a lot thicker than it is over here. And usually what it is that the structural engineer will specify some minimum thickness, and that's going to be this thickness right here. And then in order to make the building easier to construct, we'll actually make the bottom of it flat and the top of it sloping. Now, that's not always necessary. And in the case of the building that we're going to be working on here, Wesley Townhomes, it's not necessary. And we're going to have a non-variable thickness, a consistent thickness to our sloping slab here. But I do want to show you that this is something that we often have to do. And the reason that we did it for this job is because what happens is that there's a large network of grade beams, ribs, and everything like that underneath. And so if we tried to sit here and slope everything, we'd have all of these kind of ribs at varying, like the top is at a varying height, and it might be really difficult to pour. It takes a lot of time and energy and things like that to do. So in this case, because we have a lot of interior ribs and things like that, by the way, we call these ribs on the interior rather than necessarily grade beams. And I think it's just because they make up a big kind of network of things, network of grade beams and support. And because they're pre-tensioned as well, so they put some cabling in there, and the idea is that it actually makes it a lot stronger. We don't need to go into the whole background of pre-tensioning and the engineering aspect of all of that. So you can see that we have jobs that are like this. So we have curbs. We have curbs here. Maybe we'll get steps in the slab. Sometimes they're big steps in the slab. Here, maybe it'd be easier to see if we make this shaded. Yeah, that's a little bit easier to see. Um, and then one of the other big things that we do also have is underneath the slab, what you can see are these little areas right here, like what I'm selecting at the moment, right? And these are thickened slabs. And the purpose is that we don't want the slab, at its whatever its thickness is. I think the slab is what? It's 4 inches thick, right? We don't want that to sit directly onto the grade beam, where you've got like a 90-degree transition at the grade beam. So what you can see that we do, if we let's just go ahead and then let's maybe select one of these grade beams as well, just to let's isolate these. So what you can see that we do is we have a little sort of trapezoidal or triangular section, and this is poured with the slab. And this is about making the connection between the rib and the slab stronger. Because if you do a 90-degree connection, if you have a background in structural engineering, what you'll know is that this creates what's called a stress concentration, and this can break a lot easier. But when we make it a 45-degree angle, it's a lot easy. It's a lot better. And actually, the best way to do it is you have kind of like a curve in here, but that's extremely difficult to pour. So this is a good way to get it done and still keep it strong. So this is the general setup of these sort of systems. And then there's one other thing I want us to take a look at. What we also have is what you'll notice in some of these places um, is that these interior ribs, right, are not as deep as the exterior ribs. So the ones on the inside are not as deep as the ones on the outside. Sometimes they match up, or sometimes, in certain places, we make some of these, a few of the interior ones as deep, but you can see that there is this interior one that steps down. So what's going on there is that this depth of rib is needed for the structural strength and everything like that. So like to actually make everything strong, this is all that's needed. But when we're in, especially like kind of farther in the northern hemisphere, and we're in places where we have to deal with snow and frost and really like freezing temperatures and things like that, one of the things that we have to worry about is what's called frost. And frost is basically when the ground freezes. And the problem is the ground will freeze and thaw and freeze and thaw, and it will push our structure. If it's not deep enough, it'll push our structure up out of the ground a little bit here and there. And as we know about concrete, if it moves a little bit, well, then it's going to start to break, and we're going to get cracks, and we're going to lose our strength, structurally speaking. So what we do to combat that is we say, okay, on these areas that are on the outside, that are close enough to the outside of the building, where they have to worry about the freezing and thawing and the frost, we make them deeper so that they can reach that frost depth. So usually, what that depth is about 3 foot, or it's at least 3 foot, 3 foot six, maybe a little bit more, depending on the area, depending on the design by the contractor, or sorry, by the civil engineer or the structural engineer. Usually, that's 3 foot six below what the grade is. And let's remember that grade is where the soil is. It's not necessarily the top of the slab. It might be, but it's not necessarily that. But so what we have to do is we usually have to get this at least 3 foot, 3 foot or 3 foot six below grade, below where that soil is. And it's better to be a little bit conservative and have some extra spaces there. So, or sorry, have some extra space in there. So basically, even if if here the grade is up really high, it's better to have a flat bottom because it's a lot easier and cheaper to construct than it is to, say, slope the bottom with the grade. So essentially, as a summary there, what we're saying is interior ribs are usually not as deep as exterior ribs because the exterior ribs have to protect the interior ones and everything and all the structure inside from frost, from freezing, everything like that. Now, the job that we're going to be working on, this is this Wesley Townhomes, or sorry, Wesley Towns. It's not nearly as complex as Aspirin Park. Thankfully, we do have some interior ribs here and things like that. Uh, but for the most part, these are smaller buildings. They're not stepping nearly as much. There's not as many of them, and there's just these exterior ribs, and we'll go through all of these in our set of training videos here. The purpose of all of this is so that we're going to get used to uh, reading design drawings, building these buildings, and going through and doing the sheet setup and annotation of all of this. So with that in mind, this is the approach we're going to take, and we'll get into the design itself in the next video. Oh, and you can also see a little bit more here about, thankfully, this architect actually built a model. We're going to have to go and build another model because theirs is not exactly correct, and we also were not sent the model for this project. But you can see generally how this is looking. Flat slab with some sloping garages. So next video, we're going to get into starting to read the design drawings a little bit better.